We're going to be writing the equations of parallel lines today. So first let's talk about what it means for two lines to be parallel. Two lines are parallel when they do not intersect at any point. They look like the lines we have below here. We have two lines. They are following the same path on different, separated from each other, so they're not going to cross. Is it possible for two lines to look parallel but actually not be? I think I'm missing a letter here. Not be. Yes, it is possible. If the slopes are just barely different, they might look parallel but not be. So we need a better way of determining whether two lines are parallel other than just our eyesight. So one of the ways we can do that is looking at the slope of the lines. This blue line, so if I look at this point here, it goes up 1 and over 2, up 1 and over 2. So my slope is 1/2. And if I look at my red line, from this point here, it's up 1 over 2, up 1 over 2. So they're continuing to follow the same path, up 1 over 2. There's no way they're going to meet each other. So we find that two parallel lines have the same slope. Let me finish writing that. M equals 1/2. So two lines are parallel if and only if they have the same slope. Now this statement, if and only if, is often abbreviated with an IFF, two Fs. And it means the statement goes both ways. If we know that they're parallel, we know the slopes are the same. And if the slopes are the same, we know they're parallel. It's a back and forth. Either one can help me prove the other. So the first thing we looked at was, can we look at some graphs and determine if they are parallel? And I'm going to just make this bigger so we can find the slopes a little bit better. So as we find the slopes of these lines, we're looking to see which of them have the same slope. So the first line A on the first graph is up 1 over 3. The second one is up 1 over 3. And C is up 2 over 1, 2, 3, 4, 5. So although C looks like it could almost be parallel, it is not. So we can say A and B are parallel. A and B are parallel. The symbol for parallel mathematically is two vertical lines. So we can say A is parallel to B. And sometimes we put arrows on that so it doesn't look like a bunch of L's. So we're going to do the same thing for the second set of graphs. Our slopes from this one is down 1 over 1, 2, 3, 4, 5. So negative 1/5 is the slope here. And then the next one is down 1 and over 1, 2, 3, 4. So this one is not parallel, even though it looks like it could maybe be. And then C is down 1 and over 1, 2, 3, 4, 5. So we also have a slope of negative 1/5. So A and C are parallel. A and C are parallel. Now what if you're given the points that they pass through? Line A passes through negative 5, 3. And so line A, negative 5, 3. And negative 6, negative 1. And line B is 3, negative 2. And 2, negative 7. So if I want to find the slope, if I want to know if they're parallel, I need to find the slope. So we're going to use our slope formula. M equals y2 minus y1 over x2 minus x1. And we get M equals, let's color code some of this. We're going to do y2 in red. We're going to y1 in blue. We're going to do x2 in yellow and x1 in, I'm sorry, y2 in green, or x2 in green and x1 in yellow. Ay, ay, ay. So that can maybe help us see it a little bit better when we're calculating the slope. So I have -1 minus 3 over -6 minus -5. And that minus a negative becomes plus a positive. So I end up with -4 on top and then -1 in the denominator. So -4 divided by -1 is +4. So the slope of line A is +4. So in order for it to be parallel to line B, the slope for B has to be 4 as well. So let's see what 4 is. Again, we have colors. So we have -7 minus -2 divided by 2 minus 3. All right. Always y is on the top. I see a lot of people's homework with it reversed and you're getting the wrong slope. So remember that minus a negative becomes plus positive. So -7 plus 2 is -5. And 2 minus 3 is -1. So we get -5 divided by -1, m equals 5 in this case. So because the slopes are not equal, they are not parallel. And then the other thing we need to be able to do is write the equation of the line if we know it's passing through this point, 5, -4, and it's parallel to the line y equals positive 2x plus 3. Well, if it's parallel, that means the slope is the same. The slope of this equation is 2. So we know m equals 2, and we have the point 5, -4. And we can learn what we used yesterday, the point slope form. Y minus y1 equals m times x minus x1. And we can throw some colors in here too. So let's see, let's make m blue. We'll make x1 green and y1 yellow. Oops, back that up. Y1 yellow, x1 green. And then we're going to plug them in here. So we get y minus -4 equals 2 times x minus 5. And we need to, let's see, simplify. Minus a negative becomes plus, so y plus 4. Distribute my 2, so that means 2x minus 10, 2 times 5. We have to multiply both terms inside the parentheses. And then we get y by itself by subtracting 4. And we get y equals 2x minus 14. That's our final answer. So this line has the same slope to y equals 2x plus 3 and is parallel to it, and it passes through the point that was given to us. And write the equation of the line that passes through -4, 2 and is parallel to the line y equals 1/4 x plus 1. So the slope here is 1/4. If it's parallel, the slopes will be the same, so m equals 1/4, and the point is -4, 2. I get y minus y1, 2, equals m 1/4 times x minus -4, and that becomes plus a positive, so y minus 2 equals 1/4 x, distribute to the 4, 1/4 times 4 over 1 is 4 over 4, which equals 1, so plus 1, and then we're going to add 2 to both sides to get y by itself and put it into slope-intercept form. Y equals 1/4 x plus 3. So this line is parallel to 1/4 x plus 1 and passes through -4, 2.